Hello, hello. Is this working? Hello there. Okay, cool. So So, welcome back. Unfortunately, the last stream I did where I was looking at filtering using nominal categories was cut short. So we're just going to have a pick up where I left off. Basically, this is a series of streams where I go into how to build a recommender system on a synthetic data set that I've made for real estate. It's a house data set. So if I share my screen, oh wait, no, I think it's that one. Yeah. You can see I've got some postcode data from the UK government and a synthetic house recommendation data set, which I created. And you can see these are the values inside of the data set. And right now, I'm calculating what's the best way to filter the house data set using house type. So I've tried a bunch of different methods. I've tried using .query. Oh, why is that failing? Name house data is not defined. Oh, I've got to run all through it again. Okay, fine. Basically, oh, maybe I'll uncomment all of this. So I get a p run for each of them. Basically, I've investigated a bunch of different methods to see which one is the fastest for filtering, and found that you can't do much better than the prun escalative is in. Sorry, can't do much better than numpy.isin. So what I say is, given I've got some values, and given I have some user house types that they're interested in, so I've written these off of Rightmove basically. So the user can say, oh yeah, I'm interested in terraced houses, or I'm interested in semi-detached houses, or whatever. And the numpy.isin function will check if the house type in the house data is contained within the type that the user is interested in. Oh, what's happened here? Get distance by postcode is not defined. Oh, that's annoying. What's this? Extract features, fine. Let's just do it from this one down. Undo cell restock. How do I do it from this one down? No, that's not what I'm interested in, is it? Where do I... Cool. Okay. So yeah. So I've got my house data, and I'm going to say as the user, oh, I'm interested in terraced houses only. And so I run my housedata.query. This is a built-in pandas method. And it takes 0.013 seconds, which is 13 milliseconds. Yeah. Not bad, but not amazing. Oh well, it's pretty good. Then you can use the numpy.isin method, roughly 7 milliseconds. So if you do it again and again and again, yeah, you get a range of values. I guess it's just depending on what the notebook's doing, but you can do it in about 7 milliseconds. Then one of the options, so basically I was asking ChatGPT, like, what would you do in this situation? And it said you should try using NumPy, which I did, and so far that's proved to be the fastest that we've looked at. You could try setting things to categorical, so I tried doing that. So if you set these things to categorical type, so I came up with a new data set, categorical house type, try the query, same thing, same 13 milliseconds. Try it with NumPy, and it's the same story. It's basically the same. It takes the same amount of time. Then someone mentioned that list comprehension might be faster, and I don't know what version of Python this is, but in the most recent version of Python they made it faster, so I tried that. I mean, not significantly slower, but like about twice the time it takes to do the numpy.isin. I tried numpy.isin with values, and this is actually 3 times faster, but it doesn't index into the dataset, so this isn't including the index into the dataset call. And when you do include the call, it goes back to like 7 seconds basically. But I tried it with a series as well, so like just selecting this panda series and seeing, and you get the same thing. It's roughly 2 milliseconds. So from doing this, we can see that numpy.isin is probably the best method to use. So that's what I'm going to do. And I'm going to comment out all of these p runs because it's just annoying. You can see this is just a Boolean array, and I guess the part that takes longer is not calculating the Boolean array, but using it to index into the data set. Just checking the stream's still working. Yeah, all good. Check the thing's working. Okay, cool. So I've tested all these various methods. I know what's going to work best. What's this one? 3. Okay. So let's put another title up here. I suppose actually while we're here, that takes 13 seconds. What if I say semi-detached? Is that an example of a thing? A little bit slower. Does it give me a different answer? It does. What about this one? This does 2. How long does it take? Yeah, it's this one. About the same extension of time. What if we go... Oops. So that one's not a huge amount longer. What about this one? Not a huge amount longer either. Okay, so we can just, I'm just checking that just to show that it kind of still works for user house types chosen of multiple lengths, because presumably the user will be able to choose more than one. They might want to choose more than one. They might want terraced houses and flats. So basically what I'm saying there is often it's best to create an algorithm that's general as opposed to like something that's very specific for your one use case, because it means you can reuse your code, and then you're obeying the software design principle dry, which is don't repeat yourself, which is where, say you've got 3 related use cases, you write a piece of code for each of them that's slightly different but really should all be compiled into one with options. So let's say data set or something, I don't know, and say it takes data set, call it X, yeah, maybe data frame. I really don't like that standard naming scheme. I don't know, you can always change it at a later date. Column string and search list of type any. I'll show you how you can fill in a docstring like this. So basically this is the function signature, and all I'm really saying is I want this to be a very general function. I want to be able to take a data set as a data frame, or maybe I'll call it df. Yeah, that's nicer. Should I call this col? Yeah, sure. So I can take a data frame that's got some values in, take a column that I'm going to search, and then I have a search list which I'm going to apply to the column effectively. So I'm going to search for items in this list. If the column cell contains an item in that list, I'll keep it. If it doesn't, oh, actually, I suppose I should say keep boolean equals true. And basically, this is I use this to say whether or not I'm going to keep it or remove that item. Okay, so let's do this. So new df equals df numpy.isin df col search list. Okay, so if keep, we're going to do that. Else, we're going to do the opposite of that, which is this. Return UDF. Cool. Okay, that should work, I think. So let's, oops. Let's try this. So I've got this thing now. Let's say filter dataset. Oops. House data. House type. Terrace. And I want to keep. Oh. It gives nothing. Should that be a one of those? Bam. Oh no. DF col. Terrace. Oh, is it terraced? There we go. Yeah, nice. Now, let's say I say keep equals false. What now? So I get everything else. And if I do dot value counts, I can prove that I get everything else. Hashable type list. Oh. Yeah, there we go. So I've got park, home, land, bungalow, detached, semi-detached, flat, but no terraced. And then if I get rid of keep, I get just terraced. Sweet. There we go then. That's that function complete. And I can now use that in the ranking system. So build the overall feature extraction script. And I'm going to define this up here. It's not a script, it's a function. Cool. Okay. So, def rank houses. Oh yeah, I forgot to show you this. So, if you may have seen me do this, you may have not. Basically, one of the interesting things about Python, writing Python code, etc., is that you can write really nice Python code, really know what you mean, really obey the principle where you try and make your code so good that the code is documentation, basically. That's the idea. So you write it in such a way that it's difficult to misunderstand what you were even saying. And obviously, if you know a little bit about Python code, you can probably look at what I've written there, the filtered data set, or maybe I should call it filtered data frame or something, and figure out what's going on very quickly. But docstrings also help a lot. But writing a docstring can be a real pain. Because you have to you sit and you think about what it's going to be and stuff. So one of the easiest things you can do is just ask ChatGPT to do it for you. So yeah, you can get it to write you a docstring for that. And I like to use the NumPy style because I don't know, I just find it cleaner. I think it looks nicer and it's more easy to read and understand, etc. So yeah, so now I can just copy this, paste it in here, and hey presto, I've got a good docstring. So filter a data frame based on values in a specified column. This function filters rows in a data frame based on whether the values in a specified column match the values in the provided search list. So I would actually take this out maybe and put it in, well, no, actually no, I'll leave it in there, that's fine. And I like to have a space as well. I just think it's nicer, easier to read. Data frame to filter, the name of the column in the data frame to filter by. The data frame by, if true, default keeps the rows where the column values on the search list. The filter data frame. Yeah, nice. Easy enough. So yeah, that's a nice way of doing that. And so I can then create a function for ranking houses. So I'm going to take in house data. And basically the filter function that I made is general, but applying it to the data set initially, the house data set initially, means that I can reduce the data set down quite quickly, and that makes all the onwards calculations faster. So that's the reason for doing this first, basically. What do I want to say? House data, pd.dataframe, and user vector dict any. What do you do, like str any, something like that? And it's going to return pd.dataframe. Okay. Similar thing, I'll fill that in once I've actually done it, basically. So let's do the filter data set. I'm going to say house data. Nice. Is that going to be? No. Is filter data set already a thing? No, it's not. I wonder how fast that is. Too late now. Filter data set. What was this one? Column is house type. And the, so let's just say df equals that. Column equals that. Keep, obviously. And search list equals house types. Okay, there we go then. Nice. Yeah, so yeah, so now I've got the filtered data frame instead, which I can work on. Okay, so yeah, that's it basically. That's how you check various methods, how you turn them into a function, how you create a docstring very easily, and how you then start compiling it into a feature ranking, a house ranking recommender. So yeah, see you in the next one where I'll be working on price. I'm figuring out how to extract information from that. I mean, do I need to extract information from that? Yes. Yes, and I'll explain why in the next one. See you next time. Bye.